In this problem, we are asked to suggest the separation scheme to separate three proteins A, B, and C from each other. And you're provided with some protein characteristics such as molecular weight of each protein, their pi values, and their affinity to galactose, so ability to bind to that sugar. And so, of course, you will not be able to separate all three of these proteins just using one method. So most likely you will need to use two, because if you consider the first characteristics, molecular weight, proteins A and B have too close molecular weight to each other to allow for good resolution of those peaks, right? So if, for example, you use size exclusion chromatography, which is also known as gel filtration, then most likely what you will see is those two proteins that kind of, vice versa, right? Yeah, I should flip. Let me start it all over here. So I'm going to draw that elution profile for size exclusion chromatography, and the first will be protein C, and then you will have most likely B and A not well resolved, right? So, you can get those fractions, and then here it is unlikely. You still can have some fractions that have just B, but you may still have a little bit of A in here. So that is not a reliable method to separate B from A. But you can use size exclusion chromatography as your first step, for example, to separate protein C from a mixture of A and B. And then the second procedure should take into account differences between protein A and protein B. And as you can see here, the pi of those proteins is pretty different. So if you are using a pH of about, let's say, 8, 9, right, then we have protein A negatively charged, and protein B is still positively charged. So you can use either cation exchange chromatography. So cation exchanger will bind B but not A, or anion exchanger you can also use, because it binds A but not B, right? So ion exchange chromatography allows you to separate the two. Another characteristics that you see here, a second step, would be affinity of protein B to galactose. So you may want to use affinity chromatography. With the beads containing galactose attached to them, and so your protein B will be bound to that, right? Protein A will not be bound, and that will allow for separation between the two proteins. So this is your choice, what to use as a second step.